Okay, so we are going to start with the new chapter, which is rate of a reaction. To understand the rate of a reaction, we will first discuss the collision theory, and collision theory basically explains how the chemical reaction proceeds. Okay, so what happens during the chemical reaction? The reactant particles actually do collide with each other, and due to that collision, that they turns into uh, turn into product. If they collide, then they will turn into product. So these collisions are of two types. If the reactant particles which are going to collide with each other and they are colliding, they have either energy equal to or greater than EA. What does EA means? EA means activation energy that we have discussed in our last chapter as well. So if the particles have energy either equal to this energy or greater than that, then on collision they turn into products. And this kind of a collision is called successful or effective collision. Then if the reactant particles having a lower energy than this activation energy and then they collide, then those collision does not leads to the formation of the product and no product will form, and that is called ineffective and unsuccessful collision. Is this clear? Yes, Khatija
Yes,
and
sir.
Mustafa? Okay. So for how or when the effective collision will occur, it's only occur with those reactant particles who have energy, who their kinetic energy must be equals to or greater than activation energy. So if the particles have this much amount of energy, then they collide successfully and turn into product. Is this clear?
Yes, sir.
Okay, Mustafa, I will send it. Okay, complete this, then we will discuss further. This is everybody done till here?
Yes, sir.
Okay. Then we have activation energy, and we have discussed activation energy in the previous class as well. Till here you have done? Okay. So okay. So activation energy we have discussed in the previous class as well. It is the minimum amount of energy that particles, reactant particles must possess to form product. So if the particles have at least this amount of energy or greater than this, then conclusion they turn into product. Otherwise not. Now rate of reaction. So rate is change of something per unit time. That is the normal or a simple definition of rate. So here we are talking about a rate of reaction. So what actually occurs in reaction? In reaction, reactants are being used up because they turns into product and products are being formed, right? So it means that the amount of the reactants are decreasing with the passage of time and amount of the product is being increased with the passage of time. So that change in amount of reactants or product per unit time is called rate. So if I have to calculate the rate, I have to take the change in amount of reactants or product, whatever is given in the denominator, in the numerator, and the time in which that change is taking place. I keep it in the denominator, and then if I'll solve, I will get the rate of reaction. Is this clear to all of you? Okay. So we know as the reaction proceeds, the reactant decrease their amount because they are being used up. Product is forming, so their amount is increased. So, okay, one more thing. We have just observed that product is formed due to collision, right? So if the collision occurs slowly, then product will form slow. And if the collisions will form fast, it means that the frequency of the collision or the number of collisions per unit time will occur more quickly, more oftenly, then the product will form fast. So it means that rate actually depends upon this frequency of collision, that how the collisions are occurring. If they are they are occurring more frequently or they are occurring less frequently. If they are occurring more frequently, then it means the product is forming quickly. So it means the change in amount is rapid, is quick. So the rate of reaction will be higher, will be faster. And if the collisions occurring less frequently, then the rate of the reaction would be lower. Is this clear?
Yes, sir.
Okay, so complete this, then we will continue further. Is everybody done till here? Yes, Khatija.
Yes, sir.
यस सर सर थोड़ा सा ऊपर स्क्रॉल करेंगे
Okay. Is this fine?
या
Okay. Now, factors which can affect the rate of reaction. So the first factor is concentration. What does concentration means? Concentration is basically tells us that how much solute is present in the solution. Do you know what is solute? For example, if in a glass of water I add a small amount of a sugar, so that sugar is a solute. So in the mineral water, the minerals which are dissolved all are considered as a solute. So it means that if we have a 1 decimeter cube of a solution, which means 1 liter of a solution, in that 1 liter, how much number of moles of solute are there? That is concentration. So it is moles per unit volume. Okay. So if the solution have a more number of moles of solute dissolved in it in a unit volume, then it is considered as a concentrated solution. And if there are lesser number of moles of solute in a unit volume, then it is diluted solution. Is this clear? Yes, Khatija and Mustafa. So we have two types of solution over here. The one with the solution is concentrated, and in the reaction we use that concentrated solution as it's concentrated. So we know that there are more number of moles present in per unit volume, right? So it means that the particles are closer to each other. And if they are closer to each other, then the collisions will be more frequent. The frequency of the collision will be higher because they are closer to each other. They will be going to collide with each other very frequently. And as a result, the rate of reaction increases. And if we use the diluted solution means that there are lesser number of moles of solute in a unit volume. So if there are lesser numbers, so the particles are far from each other, they are further away. So the frequency of the collision will be decreased because if they are further away, they are far, so it will take time to come close to each other and collide, right? So as a result, the rate of the reaction will decrease. Is this clear?
Yes, sir.
Okay, complete this quickly. बहुत जल्दी आ रहे हैं भैया आप लोग। और लास्ट क्लास में कहाँ थे? सर लास्ट क्लास में 1 बजे थी। और आपकी? सर मुझे जाना है। लास्ट वीक पूरा ही नहीं आया था आप? ये झूठ बोल रहे थे। पहले नहीं आया। आप नहीं सर। और आज क्यों इतना लेट आ रहे हैं ये बताएं। सर से वो एक दिन निकलने में देर हो गई और वो सर सर ये झूठ बोल रहे हैं, खाना खा रहे हैं। सैंडविच सर थोड़ी सी देर हुई थी, लेकिन वो ऊपर से नहीं 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 कोई ध्यान नहीं था। मैं आ गया।
Done, sir.
Okay. हाँ भाई कर लिया सबने। आप लोग तो अब जरा मुझसे ग्रुप पे याद कराइएगा, सो आई विल सेंड द नोट्स। सर याद ही करा क्यों मैसेज ही नहीं, तो ग्रुप से मेरा नंबर निकाल के कर सकते हैं ना मैसेज, तो मैं आपको शेयर कर दूंगा। डन।
Yep.
ओके, यस खदीजा, आर यू देयर?
Yes, sir.
Okay. Now, the next factor is the pressure which can affect the rate of reaction. But do remember that pressure is for gases only. If the reactants are, if any of the reactant is a gas, then we can use the pressure as a factor. Rate of reaction. We are done with the energy changes. Now we have started the rate of reaction. So its effect is same as of concentration. Okay, how a pressure of a gas can be increased? It can be increased only when you compress the gas. So when we compress the gas, the pressure is increased, and on compressing, the particles come closer to each other. And if the particles come closer to each other, then there are more particles in the given volume, right? The in the smaller volume, there are more number of particles which becomes closer to each other, and when they are closer to each other, then they can collide more frequently. Hence, the frequency of the collision would increase, and as the frequency of collision increase, the rate of reaction increase. Now, what happens when the pressure is decreased? When we decrease the pressure, actually we decrease the pressure by expanding the gas. So if the gas would be expanded, then what happens to the particles? Space they get further away from each other. There are now more space between the particles, and as a result, in the that specific given volume, there are lesser number of moles of gas now. So if there are lesser number of moles, they are far from each other, so they are going to collide less frequently with each other due to a greater difference between them, among them, and hence the rate of the reaction would decrease and the speed slows down for the reaction. Is this understandable?
Yes, sir.
Okay, complete this. Just let me know. Yes, so concentration and pressure has a same effect on the rate of reaction, but concentration is applied for our solutions and the pressure is applied for the gases when they are reactants. Okay. Now, after this, the next factor is the surface area. So, surface area is basically of solid. So, there are two types of solid. For example, we have a two pieces of solid with the same mass. What we did with the one solid, we broken down and crushed it into a powder. So, which one has a greater surface area, the one in the powdered form or the one with the solid piece?
Powder form.
Powdered has a more surface area. Yeah, it is because think when there is a whole solid, there are only particles which are on the surface can react with the other substance. But when it comes to a powder, the particles, the molecules which are on the inside of that whole solid are also exposed to the liquid. So that's why it has a greater surface area when it becomes powdered. So powdered one has a greater surface area. So due to the powdered form has a greater surface area, so more particles are exposed to the other reactant. Hence, the frequency of the collision will be greater and the rate of the reaction will be higher in the powdered solid. And when there is a large lumps of the solid, there are only the particles which are on the surface is exposed to the other reactants. So there are less number of particles which are exposed. So the frequency of the collisions would be lesser and hence the rate of reaction would be slower. Is this clear? Yes,
Yes, sir.
Khatija?
Yes, sir. Clear.
Okay. Complete this.
सर वो दूसरा ने क्या लिखा है जो दूसरा वाला साइड है
Large lump of solids,
सर नहीं वो दूसरा वाला
powdered solid. Is everyone done till here? Yes, Khatija?
Yes, sir. Done.
Now we have next factor is temperature. So how temperature will change, will affect the rate of reaction. If we lowers the temperature, the kinetic energy of the particles would be lesser. So there are less number of particles. Yeah, very good. But you have to explain it in the continuities. The particles energy would get lesser. So there are lesser number of particles who have an energy greater than or equal to activation energy. So those number of particles become lesser. Hence, lesser number of frequent successful collisions and the rate of reaction would decrease. And when the temperature goes higher, the particles gain energy. The kinetic energy of the particles get higher. So there are more number of particles who have an energy greater than or equal to activation energy, which leads to more number of successful collisions, more frequent successful collisions, and hence the rate of reaction will increase. Is everyone done till here? Yes, Khatija, are you done?
Yes, sir, done.
Okay. Now, after this, we have a catalyst. So what catalyst do? Catalyst speeds up the reaction by lowering the activation energy. It gives you another path for the reaction to occur with a lower activation energy, and as a result, there are now more number of particles who have a energy greater than or equal to the new activation energy, and as a result, frequency of the collisions would increase and the rate of reaction would increase. Here, after completing this, see these pictures. Okay, first do this, then I will show you.
Sir?
Yeah. Okay. Now complete these diagrams. These diagrams also show the path of with the catalyst. The lower arc represents the activation energy when the catalyst is added. So complete this, then I will discuss further.
उससे लड़ने के लिए एक्सो है क्या अभी लाइफ इज एक्चुअली है चलो मैडम से बात करें प्रोडक्ट्स नहीं ये प्रोग्रेस प्रोग्रेस है ये पूछ रहा हूँ ये हेल्पी हेल्पी एक्चुअली रिजल्ट मुझे क्या आई डोंट नो मिस्टेक मेरी डील करेगा फिर आपने जो किया भी नहीं आप नहीं होगा मैं जाऊंगी मुझे वो पेपर मुझे हफ्ते में चार दर्ज कराओ यार आते ही नहीं है मटन वाला दवा बता देते बता है तो हमारा लगे 3 पता है हमारा अंदर लोग उस सीट पे एक का
Yes, pretty well. Okay, so you have to keep in mind, see over here, when the catalyst is not added, the reactants are at this energy and they need this much amount of energy to turn into product. But when the catalyst is added, see this amount of energy needed by the reactants to turn into product would get lower. So sometimes examiner asks you by providing a graph like this and then ask you to show the effect of catalyst. So you have to draw the another arc like this. Is this understandable? Okay. Yes, Khatija?
Sir, I have a question that how the activation energy is lowered. Like,
It provides an alternative path. If you can relate it with this, for example, if there is a place where some persons where some you can think some people are standing over here, okay, and they have to, and this is the mountain, and from this mountain they have to reach at this destination. So one way is this, that they can pass the mountain like this, and there is another way. Instead of this, they form a tunnel, and then if there is a tunnel, so everyone can go through this. So it's an alternate route, and this tunnel doesn't require that much energy instead of climbing the mountain, right?
yes, sir.
So that's what
Thank you.
catalysts do. Is this clear?
Yes, sir.
Okay. So here, these are the 4 points of enzyme just completed, and we will end the class over here. That enzymes are the biological catalysts. They are made up of proteins, and they also speed up the reactions in the living organism, but they uh, speed up much faster as compared to the normal catalysts. And enzymes are specific for each reaction. It means that for every reaction, there is a different enzyme every time. Okay. Okay. You're done, you can leave.
Done, sir.
Okay.
May I leave?
Yeah, you can leave.
Allah Hafiz.
Allah Hafiz. Yes, are you guys done? Okay, so take care, everyone. Allah Hafiz.